Let's take a look at skill number 20, simplifying fractions. One thing I noticed when we were multiplying fractions this week is that some of us are still having some difficulty with putting that fraction in simplest form. To write a fraction in simplest form, divide both the numerator and the denominator by their greatest common factor, or GCF. Now there are different ways of finding the GCF. In this example, where we are writing 16 over 100 in simplest form, they show us the steps, and they show us one way to do GCF. I'm going to show you a couple of different ways here in just a second. So step 1, it says find the GCF of 16 and 100. To do that, you can use the prime factorization of the two numbers. Remember that prime factorization, the prime numbers are numbers that are the only way that you can get that number is to multiply it by 1 in itself, so it only has two factors. So we have discussed prime numbers before, so I think it would be a good time to write them down up to a point. So the very first one is 2, and then 3, and then 5, and then 7, 11, 13, 17, 19. And for this you probably won't need to go any higher than that. Remember that 1 is not a prime number because it only has one factor. 1 times 1, there's only one factor, and that is 1. 2 has two factors, 1 times 2, 3, 1 times 3, 5, 1 times 5, 7, 1 times 7, 11, 1 times 11, and so on. A number like 4 would have three factors because 2 times 2 is 4 and 1 times 4 is 4. So 2, 1, and 4 are all factors of 4. That means that it is a composite number rather than a prime number. So here they've taken the prime factorization of 16, and we've learned this one previously. 2 to the 4th power, or 2 times 2 times 2 times 2, is 16. 100 is 2 times 2 times 5 times 5. 2 times 2 is 4, 5 times 5 is 25, and 4 times 25 is 100. Once you have the prime factorization, you have to be very careful to get prime factorization correctly. You can circle the numbers that they have in common. So they have a 2 in common and they have another 2 in common. So 2 times 2 is 4. Another way to find the GCF, and I prefer this method to finding the prime factorization, is to take your two numbers. This is called the ladder method. And we're going to put them inside what looks to be an upside down division. And then I'm going to use my prime factorization list, and I'm going to go up and ask, is 16 and 100, are they both divisible by 2? Well, yes they are, because they're both even. So I'm going to take 16 divided by 2 is 8. 100 divided by 2 is, 50. And then I'm going back up to my list. Can I divide 8 and 50 by 2? Yes, I can, because they're both even. So 8 divided by 2 is 4, and 50 divided by 2 is 25. Now I'm going to take these two and look up here and ask, can they both be divided by 2? Well, 4 can because it's even, but 25 cannot. So I'll go to the next one. 4 is not divisible by 3. So I'll go to the next one. 4 is not divisible by 5 or 7. So we know that now these two numbers are as far as they can go because they do not have any prime factors in common. So we take these two. 2 times 2 equals 4. Again, this is the method I prefer. You can use a factor tree. You can use prime factorization like they did here in step 1. Or you can use the method that I did. Again, you may also just continue to divide until you get to the correct number, but if you learn to find the GCF first, it's going to be a lot quicker. Alright, so once we've found the GCF, then we divide both the numerator and the denominator by their GCF of 4, and a fraction is going to be in simplest form when the GCF of both its numerator and denominator is 1. So the fraction 16 over 100 written in simplest form is 4 over 25. Let's look at example 2. Write 6 over 15 in simplest form. Here again they have found prime factorization for 6 and 15. I like the ladder method, so I would do 6 and 15. I would look at my prime factorization list, and if you need to, you can write it down here again where you can see it. And if I look at them both, and I ask, are they divisible by 2? Well, 6 is, but 15 is not, so I'll go to 3. Is 6 divisible by 3? Yes. Is 15 divisible by 3? Yes. So we'll take 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. 2 and 5 are both prime factors, so I know that they do not have another factor in common. So 3 is my GCF. So you can find it using prime factorization, you can use it, find it using the factor tree, it's up to you. And then divide both the numerator and the denominator by 3 and you get 2/5. So let's look at the examples below. Number 1 is 4/6. Well, most of us know that the GCF of 4 over 6 is 2, so I'm going to divide both the numerator and the denominator by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. 2/4. Again, I know their GCF is 2, so I'm dividing both the numerator and the denominator by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Number 3, 6/12. Now, if I don't know that their GCF is 6, I can use my factor ladder, or I can find prime factorization. So I could take 6 and 12. They're both divisible by 2. 6 divided by 2 is 3. 12 divided by 2 is 6. 3 and 6 are not divisible by 2, but they are both divisible by 3. So I'll put the 3 down here. 3 divided by 3 is 1. 6 divided by 3 is 2. Now I'm as far as I can go, so I'll take these two together. And I'll take 2 times 3 equals 6. So my GCF of 6 and 12 is 6. So I'll divide both my numerator and my denominator by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. So 6/12 in simplest form is 1/2. Let's look at number 4. Number 4, I have 8/10, or 8 over 10, and I know they're both divisible by 2, so I'll divide by 2, and I get 8 divided by 2 is 4, and 10 divided by 2 is 5. So in simplest form, 8/10 is 4/5. Let's look at number 5. 6 over 14. Again, they are both divisible by 2. 6 divided by 2 is 3, and 14 divided by 2 is 7. They're both, that is in simplest form, 3 over 7. I cannot simplify it any further, so 6/14 in simplest form is 3/7. Number 6, 6/9. They're not divisible by 2, but they are divisible by 3, so I'll divide both the numerator and the denominator by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. For number 7, 2/8, I know they're both going to divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. Number 8, they're both divisible by 3, so that is the GCF. 3 divided by 3 is 1. 12 divided by 3 is 4. Now, I know for some of you this is a very simple skill. For others, you are still having a little bit of trouble with it, so take some time. Review this video again if you need to. And when you're finished with the video and with taking notes, you're going to turn it over and you have a homework sheet. This sheet needs to be completed as part of your RTI, and so you need to go ahead and finish problems 9 through 34. And yes, I do want you to try both of the word problems in 33 and 34 down at the bottom. Make sure that you write your fractions in simplest form. If you need to find the GCF, if you can't do that in your head, then you do need to use a separate sheet of paper to do that. I do need to see your work, just the same way I showed mine. I do want you to show me where you have divided, what you divided by, so I know that you have divided by the GCF, and then show me your fraction answer. And go ahead and box in your fractions in simplest form. So the only work I really need to see is what I've shown you here in 1 through 8. If you need to show work on getting GCF, you can take out a separate sheet of paper, show your work for GCF, and then come back to this page, show me your division and your answer on this page.